800,000 PostgreSQL instances are exposed across the internet protected by nothing but a password. The vast majority of them don't even use TLS to ensure privacy of the communication. This pattern repeats for other database services with more than 1.5 million MySQL and nearly 100,000 MongoDBs, and the list goes on for more niche databases and various other types of servers. This is not surprising. Most of these applications have their own highly specific layer 5, 6, 7 category protocols, fundamentally distinct from the HTTP protocol on which the internet was built. This also entails that they have application-specific ways of handling TLS, both on the server side and the client side, which in turn differs from the mainstream HTTP-specific internet. The vast majority of tools and solutions designed to make TLS simpler on the internet will have severe limitations or not work at all for these applications, meaning teams looking to enforce privacy and security are in for a significant manual adventure fraught with complexity and outages. Unfortunately, opting out can have severe consequences. None of these applications were designed to operate on the open internet without the protection of a private network. They don't have rate limiting, brute force protection, auditability is limited, firewall options are limited by the ever more dynamic nature of the internet, and there are no means to protect against application vulnerabilities which are highly specific both in terms of discovery and mitigation. To put this into context, most of these vulnerable environments look something like this. Somewhere in a cloud, in a VPC, there is a running instance of PostgreSQL DB, which is exposed to the internet through some routing service, most often in clear text. I'm going to focus on Postgres today, but the solution works for any database or other TCP/IP application for that matter. This service is then consumed by one or more client services that reside somewhere across the internet in a local environment, personal, or a different cloud. In this practical use case, I'm going to show how mTLS identity and mTLS perimeter can help secure such an interconnected environment with very little effort and minimum to no intrusion. If you want to try this yourself, I've linked below a transcript which contains all the links necessary and shell commands, so you can simply copy and paste them as you follow the instructions. Here's a little summary of the activities for this session. Before we get to the mTLS configuration, we'll set up a mock environment first. We'll then create an mTLS identity on Identity Plus so we can gain access to the ecosystem. Then we'll install and configure the mTLS gateway, which is the role-based access control authenticating appliance. This will reside in the same VPC as the Postgres service resides. We will then configure mTLS persona, which as part of the mTLS identity product gives mTLS authenticating capabilities to non-mTLS clients. We'll do this within the client environment. We'll then change the configuration on the mock client to access Postgres through mTLS as opposed to the unprotected publicly exposed endpoint. And as a final step of the migration, when all the clients have been updated, we're going to test that everything works correctly via mTLS so we can remove the clear text routing and make the Postgres service accessible to mutual TLS authenticated clients only, like this. We will then wrap up with some closing notes. I start by provisioning the Postgres service. My routing is already defined. If you want to do this exercise yourself, you can find the cloud init file in the demo section on GitHub in the mTLS Gateway project. The link is in the transcript. It's a simple shell script that installs Docker and then runs a very generic Postgres instance on standard ports and clear text using some default admin credentials. I'm using some shortcuts in this video to minimize distraction, but in a real deployment, please make sure you follow common security practices. This will provision pretty fast, so in the meantime, I'll set up the admin connection locally on my machine. For this reason, I am copying the public IP address where my Postgres instance is exposed to create a server connection. Once done and connected, all I want to do for now is create a demo database. I will continue with the rest from a client application written in Java to demonstrate access via the native driver. Identity Plus has an identity-oriented architecture, which means you don't have individual passwords for different accounts, which then you copy for use on all of your devices. Instead, you have individual identities for each of your devices, which then you will use with all mTLS identity-capable services. This is completely backwards compared to your usual IAM architecture, but this is precisely why you'll end up working a lot less while improving security by many orders of magnitude. To name just the most obvious, with mTLS identity, you don't have the problem of secrets management. which not only reduces workload and tooling, but it also eliminates the biggest vector for mistakes around credentials and the ensuing consequences, impersonation, which is the underlying cause in 80% of the breaches. The Identity Plus ecosystem is exclusively mutual TLS-based. Every communication is possible only through mTLS-based client certificate authentication, including the dashboard. So to access it, I must first enroll my device by installing a certificate which I will get from signon.identity.plus. You'll find all the links in the transcript. Start by receiving a one-time token by email. Please check your spam folder and mark as non-spam if the email lands in your spam box, and follow the steps on the screen. While installing, you'll be asked for a device name, which is a name whose purpose is solely to be suggestive to you so you can differentiate between your devices. At this stage, please copy the password to your clipboard. It is the only element needed to install the certificate after you downloaded it. Open the downloaded file and leave everything default. When asked for a password, paste it into the field and continue with default. As a parenthesis, on Mac the installation is very similar. The only outstanding element is to make sure that you install the certificate in your user keychain, not the system keychain. You can manually create one if you don't already have. If you accidentally install it in the system keychain, please delete and restart the process. Having it there comes with strong inconveniences. Your Mac will ask for your Mac admin password each time it wants to use the certificate, which is at every request multiple times per page load, and does not give you the option to remember your decision, which you can if the cert is in the user keychain. After the certificate installs, there may be a lag until your browser picks it up because they cache TLS connections, but you can circumvent this if you open a private window. mTLS identity is certificate-based. You don't need cookies, so there's no downside to this. In the private window, go to https://my.identity.plus. When prompted for a certificate, please choose the one starting mTLS ID and hit OK. There are no username or passwords going forward. This one click is your login everywhere within the mTLS identity ecosystem. In the Identity Details section, please scroll down to the bottom and enable Developer Mode, which will show the link to mTLS Perimeter Dashboard. You only need this if you work with services, but in our example, we do. As the first step of the graceful rollout, we are going to provision the gateway in the same VPC where the PostgreSQL database resides. We're going to do this in 2 steps. Like everything in the Identity Plus ecosystem, the internet-facing mTLS perimeter protected PostgreSQL service has an identity and it's mapped as a service. We are going to configure this service in the mTLS perimeter dashboard. This is a configuration-only step. Second, we are going to deploy the gateway and configure it to route traffic to the PostgreSQL instance we want to protect. To minimize the back and forth, I will start by provisioning the VM where the mTLS gateway will be hosted. There is a cloud init shell available on GitHub in the mTLS Gateway project, link available in the transcript, which provisions Docker, clones the mTLS project, builds the Docker image, and fires up an mTLS Gateway instance. The gateway will be in an uninitialized state at this time, with no identity and no ownership, so port 80 must be open from the firewall. I recommend making it open only to your outbound public IP address. Open the mTLS perimeter dashboard. Login is the same. And create your first organization. Your list will be empty. Organization ID is important because it will be used to allocate a namespace to the organization, orgid.mtls.app, where subsequent services will be allocated. After the org is created, we'll create a service. The mTLS gateway itself does not need a dedicated service. It's a bridge for services. Once created, a domain name will be allocated, which we can use for service discovery purposes in the DNS ecosystem. I'm going to copy the public IP address of the gateway as allocated in the cloud, and I will create an empty DNS record, a root record, which then I will use to resolve the server's location and connect to it. However, to initialize the mTLS gateway, I will have to go to the IP address directly. The .app top-level domain name is a secure domain, so the browser will not accept it without a certificate, which we are yet to provision. To do so, I'm going to grab an auto-provisioning token in the service agent section and use this to provision the first service route on the gateway. To continue over TLS on the gateway, we need to tell the browser to trust Identity Plus issued server certificates. You can download the root in the server profile menu and follow the instructions to trust it. This step is unavoidable as the browser will not allow you to accept exceptions for a secure domain. Everything needs to be done by the book. Once provisioned and the root trusted, you can click Continue over mTLS. You will see the same identification process using the device client certificate without username or password, which grants you access to the gateway. As a side note, at this point the gateway closes port 80 and it will never reopen it unless you manually set it back to its pristine unconfigured form by deleting the configuration directory and all its content. Long story short, you can close off port 80 from the firewall and open port 444, which is the port the gateway operates on, to leave the standard HTTPS port unoccupied. On the overview menu, you can see some general information about the gateway, updates, stats, and your identity and role within the gateway. The basic configuration is where we will set up routing. Since Postgres is not HTTP, we will switch proxying to TCP mode. The proxy becomes completely transparent from an application protocol perspective, and we change the port to the standard Postgres port. For clarity, this port will accept mutual TLS traffic only. It will not be able to respond to clear text connection requests. When saving, the gateway will signal an error, as it cannot find the W1 subdomain for the worker service. We can solve this by either defining the W1 DNS record in the mTLS perimeter dashboard, pointing to the local IP address of the Postgres in the VPC, or we can delete it and simply add the IP-based upstream route. For this, I will grab the local IP address of the Postgres instance in my VPC and add the route in the mTLS gateway. With this step completed, the mTLS gateway now accepts mTLS authenticated clients on port 5432 and will route them over to PostgreSQL Server locally in clear text. We're almost done on the server side. We only have one configuration step left, but for that, we need the client information. So let's set up the client components also. Like services, which is a bit more intuitive in today's world, in the mTLS identity ecosystem, clients have identities too, and they are mapped into the system also as services. While they may or may not have a server profile, they do need an identity, so we can issue identification, which they can then use to identify themselves. I will basically repeat the steps I have completed for the PostgreSQL server. I will create a service with a different name this time. I will do so in the same organization, but the process is exactly the same if you do it in a different organization. In both cases, the result is a service with its own domain name allocated in the organization namespace, which is a third party to our original Postgres service, whether it sits in the same organization or not. The relationship between them will be mapped via role-based access control, which we will take care of later on. To perform actions, act as clients. Services have agents. Just like you have your browser as an agent through which you navigate the web, you act as a client to services. These agents have IDs, which we call mTLS IDs, client certificates representing the service through their agents. For our PostgreSQL client to access the mTLS gateway, we need to provision this agent and its ID on the point where the client resides. We can do this 100% programming language agnostically using the self-authority command line interface. The following steps are run on Ubuntu Linux, but they have one-to-one equivalent in every OS. I will start by making sure the Golang SDK is installed, and if not, install it. Then I will create a directory to host my mTLS-specific identity tools, clone the self-authority CLI, and build it. All of these commands are available in the transcript. You can copy and paste them. It is important to use root privileges, as the build shell script will attempt to create a symbolic link so that you can use the self-authority command directly. I will then create a directory in the etc directory to hold the client ID information and copy the ID config and the ID automation shell into the folder. The config file is very basic. It tells the CLI to simply store ID information in the current directory and how to trust the root issuing the server certificate. With this done, I will go to the Service Agents section in the Client service in the mTLS perimeter dashboard and will grab an auto-provisioning token, just as in the case of the server. And we'll use that in the CLI to provision the ID right there in the machine it will live on. Check to make sure it was successful. The token has a 5-minute lifetime only, so please do this in one go. If it expires, you can always get a new one. You can also execute an update command, which at this point should tell you that there's nothing to be done, since the certificate has not yet passed 75% of its lifetime. With this done, let's make sure we never encounter an outage due to certificate expiration. With mTLS Identity, clients rotate their own certificates independent of the service, so we can fully automate the process. To do this, simply execute the auto-renew shell script. All it does is to run the self-authority update command, which will auto-renew the ID if necessary, and it will also install a cron job, if not already installed, to run this shell every morning at 4 a.m. This ID can be used by any application programming language to establish mTLS authenticated client calls to mTLS perimeter protected services. All the client application needs to make sure of is to reload the certificate if it has been rotated automatically by the self-authority shell. mTLS is part of the TLS protocol, so it has 100% compatibility with all networking-based programming languages. That said, in our case, we don't want to touch the client, so instead, we're going to use mTLS persona, which can wrap a plain old TCP call into an agentic, identity-enabled client call. This is particularly useful when you don't have access to modify the client to make mTLS calls, such as is the case of the Postgres driver or the PostgreSQL panel in our example. I'm going to cd back into mTLS Identity Toolset directory, and I'm going to clone the mTLS persona utility and then build it, just as in the case of self-authority. It is also a Golang-based utility, so it has good OS coverage. To automatically start and restart mTLS persona in case of an unplanned reboot, you can transform it into a service using the supervisor utility on any Linux system. You can find the details on how to do this in the transcript, but I'm going to skip it here for the sake of brevity. Before I start mTLS persona, I'm going to copy the configuration file into the identity directory. I will then edit the file to define the local inbound endpoint where it will receive clear text traffic. And to point personas outbound to the mTLS gateway using the earlier defined DNS name. To redirect traffic via the mTLS channel, all you need to do now is to start mTLS persona and then change the client's destination endpoint. This should be a configuration change in all clients. Once done, test your client. This will result in a failure, which takes us back to the last piece, the role-based access control configuration I mentioned before. It fails because the client has no role configured on the service, so the gateway will deny access. We want this. The gateway will do the same to all 10 billion unauthenticated devices on the internet, resulting in a 99.59% reduction in the surface of attack of your Postgres server. No more password cracking, no vulnerability scanning, you practically disappear from the internet for all that have no relationship with your service. But the cool thing is that at the same time, you remain open to business. All you need to do to give somebody access to your Postgres server is to go to the Manage Roles section in your Postgres service in the mTLS perimeter dashboard and define a role, let's say customer. Then let's navigate in a different tab to the client to grab the service name in the clipboard. After which, in the Services section of the Postgres service, we enroll the client with the newly defined role. Now we go back to the mTLS gateway, and in the TCP config section, we simply tell the gateway to let the customer role through. You can repeat this step for any number of services, internal or third-party, and any role. With this step done, I recommend performing a thorough testing for the environment. Recheck if the client can now make a connection to the server via mTLS persona. If all works well like it does here, we are now inserting 100,000 random records into the database. I recommend forcing a certificate renewal and watching how persona picks up the new certificate. Then check if the client gracefully re-established connection. There will be a connection drop when the certificate is updated, as the old TLS connection needs to be dropped and a new one established. Your clients should be able to do this, as connection interruptions are not uncommon for network-based applications. I now recommend transforming mTLS persona into service with supervisor, and also perform a forced reboot of your client machine to make sure it is resilient across such adversity. I won't go through this in this video, but you can find the commands and how to do this in the transcript. In preparation to close off the insecure access, I will route pgAdmin through mTLS persona also, and then perform a bit of testing. Just to make sure the setup is resilient to server certificate rotations also, I will go to mTLS gateway and force a certificate renewal on the server side, and then retest pgAdmin. If all went well, you can disable the insecure ingress endpoint on your PostgreSQL service and become out of scope for cybercriminals, scanners, and other types of unwanted traffic. With this step done, you have enabled zero management, zero outage, and truly zero trust access control for your Postgres client-server environment. While it's good to monitor, you practically never have to manage this interaction. You don't have passwords, API keys, you don't need a secrets management tool, you don't fiddle with certificate rotation, as this happens on its own. All you need to do is, when you no longer need your client, to decommission or revoke the ID from the dashboard. You can scale this across any number of services, both internally for microservices or with third parties. One mTLS gateway instance can be used to route traffic to multiple services, so you only need to do this once per VPC. If you have third-party services accessing your Postgres, they only need to complete the client part of this setup, so the two of you can literally switch from insecure to highly secure in minutes and no disruption. They will of course benefit from the no management nature of mTLS identity, which effectively means that you not only eliminate your exposure, which is a vector for breaches caused by vulnerabilities lurking in your application stack, but you also close off impersonation, which is a vector primarily driven by third parties mismanaging access keys to your system. Old authentication ways, while often become unnecessary, can continue to exist. Since mTLS sits below the application protocol, there is no disruption to the old ways, only augmentation. As an important licensing note, the entire service, both mTLS Identity and mTLS Perimeter, is free of charge for personal and public benefit nonprofit organizations. Please choose the organization type accordingly. If you require an enterprise license, please don't hesitate to contact us either via LinkedIn or in our contact page. Thank you for your time.